はい、はじめまして。
はじめまして。
こんにちは。と、
Who are we?
who are we? We are just two tech guys, IT guys who appear to have been working in automotive for about 10 to 11 years.
Yes. And yeah, we thought we'll try to sort of make a show in which we'll cover everything about the automotive world that we are part of. And
We don't know everything. Mostly we are in vehicle diagnostics field, and we have expertise. We can say that 10 years it's very less time in any industry, but we can say that scan tools or diagnostic tools we have pretty good understanding.
yes, working for a decade, I think we gained a bit or two knowledge about those fields. So we thought we might share, we might explore, we might sort of create a platform where we all can explore this automotive and diagnostics in a little more detail. And yeah.
Yes, we had a little discussion like what will be the target audience. So we couldn't decide what should be the target audience actually, because it can be anyone actually. Basically, we for me, like I started as a developer in IT company. So in the beginning there was no clear direction. So that so I want to give that perspective to a new person. My personal idea is to have some kind of direction, why we have been working in this field, why should we work in this field, what are the all the
aspects of the things. And for those who actually enter into this field, who have just entered into this field, or who are not part of this field, it's important to understand that automotive is unlike other tech industries where it's not just the tech skills which drive the complete technology that we are viewing in automotive landscape, be it the autonomous drivings, chargings, battery systems, and also even in diagnostics or the connected cars, vehicle to V2X communication, etc. So it's not just the tech that is driving. Of course, tech is a driving force. The technologies and the advancements in machine learning and artificial intelligence, they are just the triggers, but due to various factors, automotive industry is driven by standards, and unless well-defined standards are created, no automotive company adopts or takes the huge automotive companies which are there, they don't take the risk of adopting these. So for professionals who are entering new into the system, it's not just the understanding of the tech that is sufficient. It is more of the standards and the driving factors.
So many standards are there. This standard, that standard, ISO standard, ASAM standard,
SAE.
So when you join some like this automotive field, you are bombarded with so many standards, and you don't understand what is the meaning of those standards. So what our aim would be, like part of it could be like how to simplify those things, where to start, how should we approach these standards also in a easy way. And actually about 6 to 7 years I was also heading towards a very wrong approach, like I didn't know how to navigate through. But once I had some clarity in mind how to utilize various layers and other things and look everything in terms of those, so it becomes very easy to understand. It's very simple also. So and apart from this tech driving the changes, I think also regulations and government agencies have a very big part in how the automotive industry and technology in it are changing.
Correct.
So yes.
It's not very easy for any OEM to just simply adopt.
So thank you governments for imposing very strict regulations like emission and other things. So yeah.
Yeah.
That is also driving force. I don't know what we should be away from any political things and everything, but yes, that is also a part.
Yeah.
Yes. So
I think with that we can at least get into things, and maybe actually that's a good start for our podcast, how the OBD or
is this a
emissions can
podcast? Okay. Okay. We don't know what it is, but yes, let's call it a podcast. We
podcast,
have
chat
not.
show, whatever it
Yes.
is.
Yes.
Yeah. And yeah.
Okay. So, so where to start? Vehicle diagnostics or?
Yeah, since we have been part predominantly of the diagnostics, yeah, I think that's a good place to start. And I think you touched upon the emissions aspect. I think that is a very good place to start, maybe because that is where uh, the sort of birth of diagnostics took place. So maybe I think we can start with that and see how we can go further.
So, first means in my mind, like when I basically diagnostic is, if we search definition, I don't know what it will come, but for me it is like if something has some problem, we have to diagnose it. For example, your body has some issue, you go to a doctor, then doctor checks, then he recommends, okay, go have an X-ray or MRI, something, so to find out what the problem is. So for me, like as a customer, when I am having a vehicle, when I for example, a bike I may be having, then the bike has some issues, like it is making some noise, or the braking is not correct, acceleration is, so we go to some dealership or some small mechanic. It's very much luck based for me, like if some mechanics are good, they tell us truth, others are not so good, or they don't have the means skills, basically they
Yeah.
replace some other part or
Yeah.
something. So somewhere for me it is very important to know what is the problem in my vehicle or bike or something, and get it repaired in the most efficient way. So diagnostics in that customer aspect is very useful and important part. So for example, yeah.
Yeah, I think yeah. So yeah, that aspect of diagnostics is very important for especially customers who purchase four-wheelers, or invest a huge amount of money in when purchasing a vehicle, and more often than not we end up taking loans as well. So it's very important that we for a customer to take care of the vehicle, and in that regards, the after sales experience which the um, uh, car maker or the OEM that we call in this industry, the OEM provides is very critical, and a lot of emphasis is given by the OEMs into the aftermarket experience, and there are many players in this aftermarket landscape. It's from a business perspective, it's not just the technician, the end technician with whom we interact with as customers. They are just the um, point of contacts, but there is a huge um, supply chain behind the how the diagnostics takes place. So yeah, I think that's a that's a pretty good
Yes,
definition.
so as you said, the technicians also, like for customers also, it's very difficult to understand, means to trust that technician, and for technician also it is a very big problem. Like some some black box came to you, okay, there is some problem, and if you are skilled technician, and often in developing countries or small places, the one technician is diagnosing all kinds of like bikes, be it Hero Honda or any manufacturer. So basically different technologies. So some technician master in some acceleration issues, like some engine related person is there in that small shop, or some other things are there. So they also have issues like how to identify the problem. So
They have their own techniques, maybe. I
yes.
never thought of this aspect, that maybe a technician, based on which type of um, uh, repairs he regularly performs, they regularly perform, I think the expertise is also built by the technician in that
Slowly,
area.
yes,
Yeah,
yes.
maybe, yeah.
And type of bikes, like one person specifies in one brand of like carburetor style is different, or the engine is like a dual piston, dual cylinder, or dual spark plug. Many new technologies are there. So basically, yeah, so they have some kind of expertise, and also for them it should be very easy to find out where is the problem, and they should be able to provide you some fix and some deadline when it will be fixed, which parts will be needed, that kind of
Understanding is needed. And also for the OEMs, the amount of time that a vehicle spends in the repair, so dealership, repair dealership, uh, a huge amount of cost is added to the OEMs. So I think they there's
warranty cost, like yes.
and they want time to repair is what we call it in the industry, and um, the more time the vehicle is off the road, I think that is a critical quality issue, and so a lot of emphasis is
reputation of company, trust of customer, many many things are there. Just not just money, but general reputation. This bike brand is bad, this car is bad, or something. This company is bad. So and word of customer flies very fast, like wildfire. Like okay, don't buy that car. That car company is bad. The service is bad. The dealership is bad, or something like that. So that is very very important. After sales is a very important part for all of the OEMs, and they focus very nicely on that part, like how to have that.
I think in that aspect in India, Maruti has the highest reputation.
Yes. When we grew up so much, like there were ads.
Even today, I think.
Even today, but Hyundai has covered some market. Let's not yes.
Let's not get.
But Maruti, Suzuki had good reputation about
for a long time.
Long time, that it's very easy to repair and cheap, and you can find technicians everywhere. And
I think they covered a huge part of India. I think that could be one of the reasons.
Yes. Good point actually with Maruti Suzuki. Even Tata trucks are there, and Ashok Leyland is also a company. So I had one discussion very old before I joined this automotive, that why Tata trucks are sold more than Ashok Leyland. Ashok Leyland has better technology, latest everything, but Tata trucks are working on World War II technology or something. I mean, now it will be different, but Ayesha is also there. So basically the technology was so old that people have understood how it works without any computers or skills, and technician know, okay, tight that screw or open that and change that part. So basically it's very old technology. It's not very efficient. It's not very how to say, if it means powerful, or some powerful is there, but so they have learned how to do that. So that's why it's for fleet owners, for example, big transportation, they will be very new technology. I don't care what technology is inside. I care about how it's easy to maintain or something like that.
Yes, I think that is a very critical aspect for fleet owners, especially. I don't know, going forward, maybe they will care with self-driving trucks and all, which are coming, cyber trucks.
Ashok Leyland had some demo for some
self-driving truck.
Self-driving or green hydrogen.
Tesla did a self-driving truck drive, right? To a long distance self-driving
truck. And Nikola also did, but it was found that it was on a slope. It had fully loaded something. I don't know. I have to check again, but some suit was there, I think.
Yeah, but I think for the viewers it's a good. I think for us also it's a good segue into. Should we talk about the history of diagnostics, like how it came about? So from my understanding, I think it was in 1970s, right? When initially diagnostics was, I think, not given a huge importance till 1960s, 1970s. I think the vehicles were pretty much mechanical, so there were very few electronic components inside the vehicle. But
it's computer-aided diagnostics.
Yeah, computer-aided.
But normal features were there, but is maybe.
Yeah, of course. Like you could do the mechanical diagnostics, of course that was important, but in terms of diagnosing what a problem is, that was never an issue because of the limited features which a vehicle had, and add to that the limited amount of electronic components inside the vehicle. But I think as the vehicle started, I think as the adoption of cars increased, there was a huge concern on the emissions which the cars were releasing, and I think during that time there was a lot of innovation which was happening in the automotive world, which with the introduction of microcontrollers inside the vehicle, which performed some sort of computation to provide various features or various functions of the vehicles, and I think that is when CARB has CARB or I don't know which regulation, but
regulations we have to check in detail.
Yeah, which body has yeah, we can I think do a video on that, but I think that is when OBD came into the picture.
Onboard diagnostics.
Yes, onboard diagnostics, and the regulation mandated that vehicles check how much it should be possible to check how much emissions the vehicle is emitting out of the vehicle through some scan tool which can be connected to the vehicle, and apart from the onboard indicators like check engine light, I think this offboard diagnostics requirements, I think or the offboard diagnostics need came into being in 1970s, correct? And I think from there, so what they pretty much what they did was they introduced an ECU which you can connect with your, let's say, a general purpose computer, and we'll get into the details I think at some point. But
ECU is electronic control unit.
It's sort of a computer which whose main purpose is to was to, at least from emissions point of view, was to the measure the amount of emissions from the chamber, gas chamber, which were getting cylinders which were getting emitted out, and and then to be able to provide that information to any regulatory body which needed it.
Basically, yeah, it would monitor all the time. It would monitor the engine parameters, like how much fuel is getting in, how much air is getting in, what is the maybe the composition of the air getting out. So that kind of information it records, and if it sees it has some threshold inside that, okay, this is the good value, and if it goes above that value, so it records that kind of information. So ECU is like a continuous black box inside your vehicle, so it records everything almost.
Yes.
And as the so originally,
I think they found original requirement was, I think,
emission
only.
So that was a government regulation, not some technological advancement or anything. So government regulation that we should be able to monitor how much pollution your vehicle is making.
Yeah,
that started basic.
And then OBD came into picture, and I think from then many OEMs realized the importance of computers in a vehicle and whole lot of things that they can do, and then pretty much it was, I think, Murphy's law, where the number of ECUs in vehicles today goes as high as, I think it can go to 80s, 90s, but on an average, I think most vehicles have around 40 to 50 ECUs inside them.
Means medium to high range vehicles. Yes, low range means depend on country also. Like when you add more components inside the vehicle, electronic components, so it cost goes up. So depending, for example, a car. Do you know that even Ambassador had ECUs?
Which only
Ambassador car had
how many?
I don't know how many, but it had emission ECU, I think, even in that time. So first I think Alto was there in India with like one car was there, Alto. So it 16-bit microprocessor or something written in behind that. So I will find that sticker somewhere. So it was the first car I thought, why 16-bit microprocessor is needed in a car. So I was not so maybe that time. So depending on the country, depending on the which vehicle, the number of these small computers inside the vehicle changes.
Yeah, at least regulatory requirement for those changes.
Basic will be there, of course. Every car, every vehicle sold will be have some mandated ECUs in it.
Correct.
Some computers to check the pollution level or emission level.
Correct. But I think today pretty much every vehicle has it, even to the extent that we started having Activa now has an ECU.
Okay, two-wheelers also. Yes, all like
even the basic two-wheelers have started having ECUs inside them. So of course there's a lot of value to having any computer today in pretty much any
vehicle
device.
manufacturers understood that they are pushing us to put some computer, why not use it to our benefit, like improving the quality or anything, like collecting some data or something like that, to improve in future. So like two-wheelers also, like fuel injection technology is there. So basically originally there were just carburetors, those are totally mechanical.
Activa has it for that only, to more efficiently manage the amount of fuel that gets into the piston, the cylinder.
So instead of that mechanical system, it has pulses of like a sprinkle air fuel mixture directly goes into your cylinder where combustion happens. So it is very controlled through an ECU. So if your vehicle has FI written, like Pulsar FI or something, then
it has that fuel injection.
And also I think all the digital meters would have some kind of digital panels,
display panels. I think those are also
originally they had some analog signals coming, but maybe now
the meters have changed. I think the meter ECUs have
even
started.
And fuel monitoring, maybe
fuel monitoring,
fuel levels.
In that.
So even in basic two-wheelers also there will be some electronic control units.
Even in electric two-wheelers these days, it's a pretty much mandatory requirement to show how many hours the battery is remaining.
So they have some app connectivity also, I think. Nowadays, so that is another topic. Connected like your.
But interestingly, the number of ECUs, I think, has hit that peak, and now it will start to reduce with introduction of
HPCs.
Maybe we'll talk about it, but the OEMs have started introducing very high powered computers in their vehicles, and to reduce the number of ECUs which is
because that first is like so many small computers, they will take energy also, like different like battery consumption. Then for each computer you have to do wiring, so that adds weight. And
adding it's not just the wire adds weight, because whenever you need to connect anything you also have to protect it, so there is a lot of plastic weight which gets added. Because I was wondering how can harness weight be an issue, that it's such a huge issue. So I didn't understand that, so I then read about it, and so there are requirements, not regulatory requirements, but these are practices which pretty much every OEM follows, where whenever you have a harness you need to have a complete solid protection to it, crash protection to the extent of crash protection. So that adds a lot of weight to the whole system, and more the harnesses more.
And all these systems are interconnected, so that is also a difficult part to make them coexist in same we call it channel or something, but same medium, like so
it's a whole world inside the vehicle where you have like these 40 computers, and they are sort of communicating with each other every millisecond. There is some communication.
Milli, micro, I don't know what I mean, we know something, but but it's very big world.
So it's a whole internet of sorts within the vehicle itself.
So where we started and where we reached also.
I think, but this I think provides a pretty much the arc of the complete diagnostic. So we want to I think just have this introduction video, but I think what we wanted to cover is take go from where it was to where it is today at least, and see how we can.
So we can have this kind of division, like we never discussed how we will do, but
Yeah.
maybe what we can do is, this is just introduction, like what we can cover, I think. But we can have some sort of playlist for like a beginner level or future things or something like that, or some playlist for
Oh, yeah.
developers or something. So we can focus on those
Oh,
topics.
that's a great idea.
So we can.
Yeah. I think in that way, then maybe we can have at least 4 categories. One could be just sort of history or stories just to explain different concepts like diagnostics, the emission history, etc. Then one could be for the developers who are in this domain, because being a developer in this domain is, trust me, very difficult. We deal with a lot of legacy codes, we deal with a lot of constrained the innovation is very slow in
Yes,
this
yes,
field.
that is good and bad also.
That's good and bad,
Like
yeah.
if you're working in some telecommunication industry or like some new, how to say, so things are changing very fast. Like you are doing some website.
Yeah, e-commerce. Like
E-commerce.
in e-commerce, you are allowed to play with different technologies.
Yes, you can be creative. You can, but here, like
in this domain, take it to any company, they'll throw that into the trash and they'll say, if it's working, don't change it.
And but yeah, so innovation is slow and it takes time. Even they trust that okay, this will work, but they don't, because there are so big supply chains and so many things they have.
There are numerous stakeholders.
So many things like we cannot cover in this one video. So let's have some kind of well-defined pathways or directions, like
for developers. Yeah, so that is one, and maybe just the domain stuff in the third category of videos, and maybe we can divide them into basic, intermediate, and sort of advanced. At least the domain parts.
Then
the
some
rest
domain part, then standards or future, what are the trends and those other things.
Yeah.
Okay, so
thank you.
Thank you so much.
Thank you for joining
and hope you have joined till this
part.
This part, yes. Thank you so much for joining,
and hope you like the video.
Thank you.